Howdy folks, Virtual Schmied here with you guys to do notes about mole and gram conversions. So let's go ahead and get started. First slide, specifically the type of conversions that we're talking about is going between moles and mass. Usually we measure mass in grams, usually we'll see that for a mass. And then moles and particles. Particles is kind of a catch-all word for whether we're talking about atoms or molecules. We can just say the word particles and we don't have to be specific. So we're going to use two conversion factors, mostly this first one, the 1 mole equals molar mass. We'll talk more about the 1 mole equals 6.02 times 10 to the 23rd atoms and molecules on a different day. What we really need to know about molar mass is that it's coming straight off the periodic table. So if I need to know the molar mass of any of these elements, I can look, and specifically I'm looking for the decimal number. So for example here, carbon, I don't want the 6, reminder that's how many protons it has. I need the actual mass of it, in this case 12.01. So that's where we're going to be getting these molar mass numbers, is from the periodic table. For these two problems, I'm just going to have you guys do some annotation along with me. So these problems are fully done. It shows all of the work, including the final answer. And we just want to annotate, all right, where did these numbers come from? Why did the 6.94 go on the bottom and not the top? So first thing, the problem says convert 24 grams of lithium to moles of lithium. This is my given number. So that's why it goes right there. We put our first given number there. We want to include the units along with that, 24 grams. And the reason we need to include the units with that is so we know where to put the 6.94 grams. We'll come back to that unit in just a moment. So the 24, that's our given. The 6.94, that's the molar mass, coming straight off the periodic table, 6.94 grams per mole of lithium. So the 6.94 is from the periodic table. And then a couple more things to annotate here. We put our grams there and our grams there so that they cancel out. So we have grams cancel grams there. The reason we care about that is so that we can get into the unit of moles, because it's asking us to convert to moles, and that's the one we want on top. So the unit we're trying to cancel goes on the bottom, the unit we want goes on top. Cool. So the unit we want is on top. Moles, the unit that we're trying to cancel, in this case grams, goes on the bottom. Last thing to talk about is what is the actual math that we did. We took 24.0 grams divided by 6.94. And just to prove that we did this correctly, 24 divided by 6.94 gets us that 3.45, and we're just going to round it to 2 decimal places, so 3.46. That 8 rounds the 5 up to a 6. And that is specifically moles. Cool. Let's annotate this next problem. So this time it starts with 6.5 moles of CO2. That is going to be our given for this one. So there's our given is 6.5 moles, which is why we stick that right in our top spot right there. The moles went on bottom this time, so that moles and moles cancel there. So we have mole cancel mole. For this 44, this is coming from the periodic table, but we have to do a little bit of addition for it. And we're going to do that right here. Since it's CO2, we have to add up C and O2. Carbon, has that mass of 12.01. Oxygen, we round these to 2 decimal places, so 15.999 rounds to 16. So carbon, 12.01. Oxygen is 16 times 2, since it's O2. And to get the 44, we are adding those two numbers together. I'm taking the 12 and adding it to, well, 16 times 2 is 32. So that's where we get this 44.01 from. It's from the periodic table with a little bit of math from us. Cool. So to finish this up, we did the same thing here, down here. Grams are on top because that's the unit we want. And moles are on the bottom because those are the units that we need to cancel out. Last thing to put. To actually do the math here, we did 6.5 moles times 44.01. And that's where we get the 287.07 grams from for that problem. All right. Hopefully that annotation was a little bit helpful. For the rest of this, we're just going to walk through 3 practice problems together, and then we will, of course, practice this more in class when you get live Schmied and not just virtual Schmied. So very similar to what we just did. How many grams are in 2.3 moles of iron? It has the symbol Fe. Well, this is my starting number. That's my given. So I'm going to set my problem up just like this guy here. So I'm going to do that and that. Maybe that's more space than I need, but that's all right. I got plenty of room. 2.3 moles of iron is going to go on our top spot. And next, we need to know, all right, how much does iron actually weigh? Well, I can look that up on the periodic table. Iron is Fe. There's Fe. We're going to do 55.85 because we're going to 2 decimal places. So for iron, 1 mole has a mass of 55.85 grams. And we need to answer, all right, how many is 2.3 moles of iron? We need to know, am I dividing or multiplying? And this question comes up a lot. Do I divide or do I multiply? Here's how we answer that. We need moles to cancel with moles. So I need moles here and moles there to cancel. The unit I want is going to be on top, so grams is going to be on top. Because I want grams. And I want to cancel moles. So to answer our question, do we divide or multiply? The 55.85 goes with the grams. And 1 mole goes on the bottom. So in this case, we are multiplying. So we're going to do 2.3 times 55.85. 2.3 times 55.85. We get 128.45, but for this, we're just going to round to 2 decimal places, so we'll go to 128.46. And we need to be specific. That is grams, since that's the unit that we wanted. And it is specifically grams of iron, or Fe. We need to be specific about what it is. All right, next one. Move on to number 2. This time we're being asked to go the other way. We are, or no, we're not. We're still starting in moles, and it's asking us how many grams. What's going to be tricky is adding up the molar mass of uranium tetrafluoride, or UF6. First thing, I'm going to start with my given. Make my cross, and I have 0.023 moles. And I need to be specific about what it is. It is UF6. Now I need to go to the periodic table to add up the molar mass of UF6. So I got to find uranium somewhere down on the bottom, 238.02. And I also need to add up the fluorine, the F, has a mass of 18.998. What's nice is we can round that to 2 decimal places for 19. So there's our uranium, our U, and then we have F times 6, so 19 times 6. Add it up on the calculator. There's 19 times 6 plus the 238.02. So UF6, or uranium tetrafluoride, has a mass of 352.02 grams for 1 mole. That is going to be our conversion factor, but again, we have to decide, am I divide or multiply? And that's just going to come down to canceling out my units. In this case, I want grams, so I want grams to be on top because it's asking me how many grams, so that's going to go on top, which means mole is going to go on the bottom. I already know how many grams equals 1 mole. It's 352.02 grams is 1 mole. So I am multiplying 0.023 times the 352.02. And we will round that to 2 decimal places, so 8.09 is going to get rounded to 8.10. We have to be specific about how many and what. We are using grams, and that is uranium tetrafluoride, or UF6. All right, one more practice problem with Virtual Schmied, and then we are going to be done with the notes, plus a little bit more practice for y'all. So, number 3, we are going the other way this time. So we're going to divide this time, and we'll talk about how and why we know we're doing that. First, we've got our given, this 23.45. That's our given, so that's going to be our starting number, 23.45. And that is grams of FeNO33, or iron nitrate. So I know that I'm going to need to know how heavy this is. If I'm going to go between moles and grams, I'm going to need to know how heavy it is from the periodic table. So I'll have to do iron, nitrogen times 3. The outside 3 multiplies in. So we got 3 nitrogens and 9 oxygens. From the periodic table, we know that iron is 55.85. Nitrogen has a mass of, we're going to do 2 decimal places, so 14. And oxygen is 16. However, I cannot forget that there are 3 nitrogens and 9 oxygens. So 14 times 3 plus 16 times 9 plus 55.85 times, well, just 1. There's only 1 iron. 241.85. And that is how many grams are in 1 mole of the FeNO33, or the iron nitrate. So divide or multiply. You might already be able to tell that we're going to divide for this one, and the reason we're dividing is because we're going the opposite direction. The previous 2 problems asked us to go from moles to grams. This time we're being asked to go from grams to moles, so this time I need grams on top. Grams on the bottom and moles on top. Grams are on bottom. 2 cancel. And we're going to put mole on top because that's what we want. And the 241.85 goes with the grams. and 1 goes with the mole. So this time we are doing division. We're going to do 23.45 divided by 241.85. For massive, well, we'll round it to 2 decimal places, so we're just going to go to 0.10. So that is going to be 0.10. We are specifically in moles of the FeNO33. And there's our final answer there. Alrighty, folks, that is going to wrap up Virtual Schmied for today. If you guys would go ahead and work on the practice next, and when I see you next time in class, we will work on some of these together. But Virtual Schmied is out.